So last week I went through the basics of supply and demand theory and how empirically the whole idea that people are utility maximizers has been experimentally falsified. I'd love to repeat that experiment and see how many commodities does it take before people can't actually compute in a way that fits the theory. I've got a feeling it's about 4 commodities at a guess. Any more than 4, because you've got 4 to the power of how many other choices you're making. And with that many choices to make, I'm sure you get people violating between 4 and 6, maybe certainly 8 commodities is enough to empirically violate the idea that they can actually make the decisions involved. Then you get the logical falsification of the demand curve idea because, again, even if you did have people obeying the downward sloping Hicksian demand curve stuff, actually behaving like utility maximizers, when you try to add up their demands, you've got to take into account changing prices. Changing prices changes the distribution of income, and you can no longer separate the income and substitution effects as they do at the micro level to do the Hicksian compensation, so the whole thing falls over. Even then, even if you say, well, first of all, you can't derive an individual demand curve using that, okay? Then you can't derive a market demand curve doing that. And so even if you could do both of those, it still doesn't behave the way they think it does, because of the nature of what actually is profit maximizing behavior. So if you look at how they justify this stuff in the textbooks, they say that there's the sheer number of competitors in a so-called perfectly competitive economy, a market, is enough to explain why they set price equal to marginal cost as profit maximizers. Now, what I want to show is that's mathematically and logically false. There is a justified way of explaining perfect competition from the point of view of competitive firms, but it's when they interact with each other. It's when they do the Cournot approach, where they actually strategically decide how much to produce based on what they expect the other person to do in a prisoner's dilemma situation. That does lead to a Nash equilibrium of perfect competition setting price equal to marginal cost, if you take the assumption of rising marginal cost, which is false, and a downward sloping demand curve, which is false, but put them both, assume them both, bang, you get the Nash equilibrium outcome. Price to equal to marginal cost is the Nash equilibrium maximization situation, not the total, which has to involve collusion. But the problem with that particular explanation is it only applies in a single shot game. When you have a multi-shot, when you're going to repeat competition time after time after time, then the equilibrium in the repeated game becomes what they call the collusion approach of, if you set marginal cost equal to marginal revenue, you have a price higher than marginal revenue, and that gives you profit maximizing behavior over time. So in that situation, competitive firms would do what monopolies do. That's why I think they don't actually use that explanation. It's a more complicated explanation. It's mathematically correct, but more complicated. And B, when you get it, it only works if you assume competition happened once and never happens again, which is nonsense, because if you're going to be a competitive firm, you're going to exist for more than one production run. So you're going to have the repeated game outcome, and that gives you competitive firms will price just like monopolies, which is not the result they want. So they don't include the stuff in the textbook. I want to show that the Marshalling one is simply mathematically wrong. I'll cover that today. Then the process of going from the idea of general equilibrium to ISLM, and when you look at it logically in terms of how this stuff is derived, it is not the case that ISLM is a Keynesian model. It is a neoclassical model thought of before Keynes, published after Keynes, and attached to Keynes because he was the popular person at the time. And you can find this all in Hicks' own logic, so I'll cover all that in today's lecture as well. Well, let's go back and take a look at this perfect competition idea, because as well as having the idea of rising marginal cost being an essential part of the theory, it's also an essential part of the theory that price is equal to marginal revenue. Okay. Now, if you have a downward sloping demand curve, because decreasing the price increases sales, you get the price reduces revenue, quantity increases, you get a trade-off between the two. Marginal revenue will be less than price. The only way you can get the idea of marginal revenue being equal to price is the argument that these terms are what they call price takers. So what they show is you have your particular price equal to marginal revenue 1. It means you're going to, that's going to be the point that you produce at, which happens to be on the marginal cost curve. If you have a higher or a lower level of price, then you're going to produce again on the marginal cost curve down here, and then a higher price, higher production level. So the marginal cost curve becomes the supply curve for the individual competitive firm, and therefore you get a supply curve. If you don't have a supply, if you don't have that, if you actually have the firm having a downward sloping demand curve, then this is the situation you get. So you have an upward sloping marginal cost, take that same fantasy into a chaos, downward sloping demand curve, marginal revenue below it. That's one combination that the firm will therefore produce, which is not on the marginal cost curve. But then if you choose and say, well, let's say take another demand curve, which happens to have different elasticities to the first one I've drawn, then you get another point. And when you take a look at that, the supply curve, you want to draw a supply curve like that, it depends upon the characteristics of the demand curve. You can't draw them independently. So that's why there's such a song and dance about perfect competition in neoclassical thought, because otherwise they can't get the idea of independent demand and supply curves and can't do demand and supply analysis. That's why they hang so doggedly to that particular combination of fallacies. Okay? Without those fallacies, they can't get to their base level of thinking about the economy. Now, when you look at how they justify, this is taken from Mankew's 2002 edition. That's because I can't be bothered paying money to Mankew for a later edition. But this is talking about firms in competitive markets, and an essential part of it here, this is the market is competitive, if each buyer and seller is small compared to the size of the market, and therefore, okay, logical derivation, because they are small, therefore, okay, it's a logical sequence, has little ability to influence market prices, okay. So it's saying that alone is enough to explain why they face a horizontal demand curve. That's the sole reason they give. In the Cournot, this is why I'm pissed off with the neoclassicals in general, of course. But people like Chris Auld and others who attack me on this point confuse the Cournot explanation with the Marshallian. They don't even realise it's a Marshallian explanation anymore, in the sense of Marshall's explanation was that firms ignore each other, okay, and face a horizontal demand curve because there are so many of them. Whereas Cournot's is they take into account each other's existence and strategically interact. They are two different explanations, but they mess the two up. So if you look at, again, this particular one, it's the same idea, many buyers and sellers, and the goods are homogeneous. All things, by the way, which abstract away what's actually interesting in capitalism. Okay? Diversity of products. Competition tends to be through innovation and non-homogeneity. But I found a more explicit statement of this, because it used to be called, when I did at my university, it used to be called the assumption of atomism. And that made it easy because I could actually point to this assumption in the text. Now people who get trained in so-called more modern textbooks don't get the same clarity of the assumption, and they can happily mess the two up. Here's the classic. Firms in textbooks behave extremely trivially with respect to rivals. They simply ignore their existence. So that's background. Can you say, starting from lots of small firms, who each ignore the existence of other small firms, do you get the result that they face horizontal demand curve, in which case price is equal to marginal revenue for them? That's the argument you get. So when you look at what this assumption actually means, it's saying the change in output of the ith firm given a change in output for the qth firm is zero, except when I is equal to j. Okay? So firms do not strategically interact with each other, whereas in the Cournot model they do interact with each other. Now, what that means, of course, the change in output of the ith firm given a change in the output of the ith firm is 1. It's a ratio of how much, Smith Dairy Farm, to use Mankew's example, the ratio of the change in output of Smith Dairy Farm to the change in output of Smith Dairy Farm. It's 1. Okay. Now that is alleged to lead to price equal to marginal revenue for the ith competitive firm, which is the model they use in the textbook. So the logic here starts in saying marginal revenue is the change in total revenue for the ith firm, given a change in the output by the ith firm, which is using the chain rule. You break it into qi times dp dqi plus p times dqi dqi. That is 1, as I've already put up here. Okay, that is supposed to be 0, so you get marginal revenue equals price. That's what they give you in the textbooks. If they wrote it down, that's what they'd write down. Often they don't write it down in mathematics. Now Stigler, this is one thing I found out after I'd written my own verbal critique of this in the first edition of Debunking, which you've got there. After I realised this verbally, and I'll point out why I worked it out during the lecture, I was then told by a friend, Stigler pointed that out back in the 57. Oh, you're kidding. Stigler, because Stigler was one of the most rabid defenders of the neoclassical faith. He was actually asked to write this article as an overview of the theory of perfect competition. I think it's called Perfect Competition, Historically Contemplated. And it's the first article in the Journal of Political Economy, which is one of the three leading conventional journals, for the year of 1957. It actually starts on page 1 of the journal. Okay? So it's an invited lead article. And he disputes the assumption that the change in market price for a change in output by a single firm is zero. He said that's not the case, because he says you apply the chain rule. He didn't do this, it wasn't done to undermine the theory. I think he worked this out while he was writing the article and then rapidly tried to find a way to bury the result. But he published them both here. So I'm now very happy to adopt Stigler's proof of this and then go forward from that point, because neoclassicals are happy to take pot shots at me, but I haven't seen any of them taking pot shots at George Stigler recently. In fact, that's the comeback I put to some of the ones who challenged me on Twitter last week. Well, why don't you take on Stigler, Why not take on one of the Nobel Prize winners and get yourself famous that way rather than just having to go at me for the wrong reasons. But if you apply the chain rule, say there's dp dqi, we can break it into the shape dp d big Q times the big Q dqi. Simple application of the chain rule. The wrong notation, I should be using partial differential equation notation here, but this is standard for what they do, so I'm using it here. So that's the slope of the demand curve facing the individual firm. It's the slope of the market demand curve multiplied by how much market output changes given an output by the change in output by the I firm. Now it's fairly easy to work out that's 1. And the logic is if firms are ignoring each other, which is the argument here, then you have the change in output for the change in total market output given a change in output of the I firm is the sum of the change in output for the J firm given that change in output by the I firm summed over all the firms from J equal 1 to n. So what you get is dq1 dqi plus dq2 dqi blah 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 out to dqi dqi plus dqn dqi. That's a whole lot of zeros plus a 1. So that's 1. That's Stigler's fundamental logic, though he didn't actually write that out in the paper. So you put that together, you then find what is the slope of the demand curve facing the individual firm. It's exactly the same as the slope of the market demand curve. It is not horizontal. Okay? Again, I cover more of this in other lectures. Again, given time, I'm not going through that right now. So it's not zero. It's exactly the same as the slope of the market demand curve. So it's a known goal. But he rescued it by a convergence argument. He said, yes, that's true when there's a small number of firms, but the more firms you add, if they set marginal cost equal to marginal revenue, which is profit maximizing behavior, you will converge on this outcome. So he said it's intuitively plausible with an infinite number of firms, all power vanishes, and you can simply show it by reworking this equation to say marginal revenue is equal to price plus price divided by the number of sellers times market elasticity of demand. And you keep on going long enough, that'll approach zero. There are problems with that as well, but the basic idea is true. Price will converge to marginal revenue, and that'll be equal to marginal cost if each firm sets its own marginal revenue equal to its own marginal cost. Now, by own marginal revenue, I mean how much its change in costs relates to its change in revenue rather than revenue for the entire market. What that is doing is solving an ordinary differential. You're saying how much your profit will change relative to your output. Okay? And you find that's rooted as zero. But your profits don't just depend on what you do. You're in a market. If somebody else changes what they're doing, whether you can influence that or not, whether you know it or not, it affects your revenue. If another firm changes its output, that will affect your price because this equation the term is not zero, it's 1. So, and even if you can't control what other firms do, you need to take that into account if you're going to be a profit maximizer. Okay? You're working out what to do to maximize your profit as a single firm in a market where there's more than one firm. You're ignoring all the others in terms of you're not strategically reacting to them, but what they do affects the revenue you get because their changes in output will change the price you see. So the real profit maximization is a total differential, and that is finding the derivative of your profit relative to total industry output. That's where you've got to find the real zero. Now, I get told firms can't know it. So the problem is fundamentally, I just found a few graphics here to have some fun with this for my students back at Western Sydney decades ago. Funnily enough, this guy's face is almost identical to who was Australia's wealthiest man, a guy called Kerry Packer. The body's pretty similar too. I met him in a swimming pool once. So work out the output level that maximises my profits. That's what Kerry Packer wants to do. And the economists are that simple, just find where marginal cost equals marginal revenue. There's the mathematician says that's an interesting problem. Solve the total differential profit, set it to zero. So I'm going to do what the mathematician would do here. And what you find is you have to find this expression. Where is DDQ of your revenue minus your costs? Okay. Where does that maximise relative to total industry output? That's the true profit maximisation point. Whereas the Neoclassicals solve this one. They do it once for the I firm only, as if that firm's in isolation in the marketplace. Now, it might not be reacting strategically to what other firms are doing, but it's not in isolation either. So the total differential involves working out this expression, how much your profit changes for a change in output by another firm for every firm in the industry. That's a change in the I firm profit given a change in the J firm's output, and you do it n times for all the firms in the industry. And then given that, you work out what your output level should be. So let's look at it. Use the product rule. You can take this expression and expand it to the, I haven't got the initial one, but that's the expansion of the revenue term. That's market price times how much a given firm's change in output affects your revenue. And you sum it over the n firms. And then minus 1 times, it's going to be 0. Okay? Because you don't react to what other firms do, but you do react to what you do. So once you're going to get one term out of that. That's going to be P on its own. So it's P times 0, n minus 1 times, P times 1 once. This one here is your output, how much you change in your output, or change in output by a J firm affects the price you face. Now, because every firm faces a downward sloping demand curve, then that's going to be substituted with the demand, the shape of the actual market demand curve. So n times you're going to get output of the I firm times the slope of the market demand curve. I'll explain this twice, by the way, because I know it's a bit messy to go through. Now, the cost component is how much your costs change given change in output by the Jth firm. Because you're a separate entity, that's 0, n minus 1 times, and once it's your marginal cost curve. That's what drops out. So the maximum profit is where, and so again, I'm going to explain this twice because I know it's a bit complicated. It's price plus n times the output of the I firms times dPdQ minus your marginal cost. That's going to give you your maximum profit. Whereas the neoclassical formula says it's price plus a single times your output times dPdQ minus your marginal cost equals 0. So they're emitting an n. And when n is really big, that's a really big number. When I first proposed this to Russell Standish, my colleague and friend and co-designer of Minsky, he's a mathematician, he's a theoretical physicist, and he thought it can't be that big, can't be. I said, check it out, and he came back and said, you're right. So that's when we published our article in the Journal of Physica A. So that n times qi is a big number. It's a small difference multiplied by a very large number, and that's why it makes the impact when you look at the formula over time. So setting marginal cost to marginal revenue does not maximise profits, as they define it. If only one firm in isolation, then what you get depends upon what all other firms do. So here's the total differential, and this is working it out more elaborately. So you're saying you want to work out for profit maximisation the point of total market output, which maximises your profit, and that's the sum over the n firms, j firms in the industry, n firms in the industry, of delta q, a partial dj times the profit of your profit, the I firm, times how much the output of the J firm changes given their terms in change in market output, which is just the inverse of how much market output changes given a change in output by the jth firm. That's 1. That term drops out. So you then drop the 1 out of the way. You've now got this expression, which you have to go through over n times. And I've now expanded it out in terms of expanding that product rule is now applied down here. So it's PQ times partial QI partial QJ plus QI times partial PQ partial QJ, which we can substitute with the slope of the market demand curve, minus the change in revenue, which becomes just marginal cost once for that firm. So that's going to be 0 n minus 1 times, and once it's going to be 1. This is going to be n copies of the slope of the market demand curve, and that's the part they're leaving out. Okay? They have only 1 copy of it, and that's going to be marginal cost. So the overall profit maximisation is where that expression is equal to where price plus n times QI dp dq equals marginal cost. The neoclassical formula says it's P plus QI. So leaving out n times the slope of the market demand curve times the output of the individual firm, which is going to be huge. Fundamentally, if you look at it, that's the term for profit maximisation for a monopoly. N times QI is total Q. It's exactly the same as a monopoly. In other words, a bunch of perfectly competitive firms, as they define them, where you don't allow them the false assumption that the market demand, the slope of the individual firm's demand is 0, don't allow them that false assumption. You find that competitive firms will do exactly what a monopoly will do. So the logic falls apart. So that's the true maximisation formula. If you have a downward sloping market demand curve, which they can't prove, I can accept that it exists in reality for a large number of products. If marginal cost rises, which it doesn't, then you set QI so that that equation is correct. Okay. Now, when you rework that or muck around with it a bit, I can now say QI dp dq is minus P minus MC divided by n. That's just rearranging that particular expression. And now I can put that into the equation there. And that bit there is marginal revenue for the ith firm. So I've got their marginal revenue now. Should it be equal to marginal cost? You can see what's going to happen. I'm going to say, no, it's got to be n minus 1 times the slope of the market demand curve times output. So I'm now rearranging it. That's the expression turning up again. And by doing all that, I finally get that's your true profit maximisation formula for any number of firms in the industry. You don't set your marginal revenue equal to your marginal cost. So that term is 0. You set the gap between your marginal revenue and your marginal cost to the n minus 1 over n times the gap between price and marginal cost. Now, if you try that for a monopoly, what does it work out for a monopoly? Where n minus 1 over n is 0. So a monopoly maximises profit by setting its marginal revenue equal to its marginal cost. But if you have a duopoly, then they set the gap to half. The gap between marginal revenue and marginal cost is half the gap between price and marginal cost. So even at this stage, what they teach is wrong. If you ask them, they'll believe the Cournot model, but the Cournot model only works if you can model competition as a one-shot game, which is never repeated, which doesn't make any sense. So they don't try pulling that one over students' eyes. They wait until after they've gone through a bit of a master's course before they teach them Cournot and Prism's dilemma and et cetera, in game theory. So it's a load of nonsense, like most neoclassical theory. It's an elaborate, convincing, false model of the economy. And it's a dead end of micro in general. So it makes factually false assumptions about firms' costs. It's got a computationally impossible model of how consumers behave. It can't explain demand curves that are essential for the theory. And it gives false advice about profit maximisation, even if its assumptions are correct, which they're not. Which is why I teach it as similar to teaching phlogiston to modern students of chemistry. Okay? It's how they used to think about how chemical reactions apply. It's clearly wrong. And that's why I don't give it serious credence. But they still think that's good micro foundations. This is why in the first edition by debunking, I focused on micro rather than macro, because fundamentally macro is derivative for them. Everything's derived from microeconomics. And I actually remember giving one talk at Monash University, and I was having a go at the macro. This is after the crisis occurred. And one of the true believers in the audience said, macro is pretty bad, but micro is good. And I just said, what total bullshit. You haven't looked at your own micro properly. It's garbage. It's convincing, but it's garbage. So if you actually had good micro foundations, you'd be describing how firms actually compete, which is mainly through innovation. Okay? You'd have consumers having limited tastes, limited capacity to maximise, so therefore using habit and so on. You talk about market segmentation. I think the best micro in that sense is done by Michael Porter in what's called the competitive advantage of nations. So if you want to go to look at a good book about how competition actually proceeds, a combination of Schumpeter on theory of economic development and Michael Porter on the competitive advantage of nations is a good vision as to how actual competition occurs and where innovation and change comes from. That'd be good micro foundation. So products are heterogeneous. We don't have phones, we have Apples versus Samsungs. And people get involved in the debates over which is better or which is worse. Consumer tastes evolve with those evolving products. And that's a major part of where capitalism has a major strength over other social systems, because that evolution did not happen in the Soviet Union. Okay, the 5-year plan, the desire to fill, the need to fill that, you literally produced last year's motorcycle every year. I'll give my personal, you may have seen me talking about it, when the brother of a girlfriend of mine back in my early 20s wanted to buy a 650cc motorbike, and he couldn't afford a Kawasaki or a Suzuki, and he found he could buy a Cossack, the Russian version. This is back in the days of the Soviet Union, which he then bought for $650, so $1 per cc, when the price for a Japanese car was about $3,000, so $5 per cc. And the thing turned up, and when we unpacked it, it was a 1942 BMW, complete with a bicycle seat. Have you ever seen Steve McQueen in the, what's that movie called? The Great Escape? The motorbike he's riding on, that's what the Russians were producing in 1972. They simply stole the design. They had reason to steal designs from Germans, obviously, and reproduced it every year. You could plough a field with the damn thing. It had such a level of torque, but it didn't evolve. So that's the advantage of capitalism. That those sorts of things happen. And demand is limited. You don't have a limitation on the cost of production limiting how much firms produce. It's the amount of aggregate demand and the distribution of income. That's what determines where firms can stop selling. And every new item sold is profit. The whole idea of a break-even point, which accountants learn, is valid. Past the break-even point, you're making profit. The role of a sales manager is to get as many sales as possible, whereas in the neoclassical model, the role of a sales manager is to stop the sales staff selling when marginal cost exceeds marginal revenue. You find me one sales manager has ever stopped a sales staff member from selling a product without being sacked. Okay, it's just crazy to say that they have a limitation based on the cost of production. And overcapacity is the rule in capitalist nations. Rather than having all your capacity used fully, you've got excess capacity, because without excess capacity, you couldn't respond to competitive advantages, and you'd have to be forever building factories the next day, because every day your factory would be reaching capacity. So you always build more capacity than you need. That's the rule, and that's what we should be studying. If we're going to have decent micro foundations, I'll be starting with the Cournot, demand-constrained versus resource-constrained economies. A brilliant vision, a brilliant little meme to say, why does a capitalist economy grow more rapidly than a socialist one? Why does innovation occur in a market economy and doesn't occur in a centrally planned one? That's a good part to start.
What about China and what about China? Wasn't the Soviet Union spending a huge amount of money innovating in military?
They did. Like, for example, that hover plane they designed, which Americans had never thought of. Mind you, nobody's actually come up with one since. It doesn't seem to have gone particularly far. But yeah, they did innovate, but the pressure, and Cournot explains this very, very well, the pressure is on you in a Soviet system to fulfill the plan.
Yeah.
Everybody, if you leave Stalin out of the equation, leave out the purges, just imagine a benevolent socialist system, and where you try to give workers as high a wage as possible, so there's tons of aggregate demand, where you're trying to industrialise, so every desire for investment goods is justified, trying to expand the overall productive capacity of the economy. That means everybody has to be rationed, because you can't get all the goods you need. So rationing means that even if the plan's perfectly fulfilled, you're getting less resources in than you need, you have more aggregate supply. There's aggregate demand aggregate demand far exceeds what you can actually fulfill. Everybody's working to full capacity. Okay? In that situation, there's no pressure to innovate. And then what you'll get is a slow growth over time. You won't get the booms and slumps of capitalism. You won't get the innovation either. It's a very, very well worked out piece of logic. So have a look at Janos Cournot for a realistic vision if we're actually doing micro. Now that's what nonetheless, they try to build their models on this micro foundation that they think is valid. But even that is wrong, because the essence of what they're doing with micro foundations is not aggregating different individuals. It's extrapolating from isolated individuals. You look at the theory of the individual consumer, they extrapolate from that to the market demand curve, which is not valid. They do the same thing for the individual firm. I haven't gone through the maths here, but again, to be able to say you can add up the demands, so the supplies of lots of small firms with rising marginal cost and get exactly the same marginal cost curve as a single firm, that involves an aggregation fallacy as well. So what they're doing is that it's extrapolating. Single firm in isolation, single consumer in isolation, extrapolate that to the aggregate level, and it simply can't be done. That's the Sonic and Mantel-Debreu theorem shows that for the demand side of things. And it's not what real sciences do either, because what they think they're doing is reductionism. And if you look at where the progress in science came from, it often was a case of saying, let's leave out all the complicating elements and just focus on one element of a system and then add it all up in a linear way to get, work out the sum by understanding the parts and adding them up. That's what reductionism, it appears to be reductionist. But as Anderson, a physicist, wrote in a beautiful paper called More is Different, that's not what they're doing. They're doing what he called constructionism. They're trying to start from the parts and add up to get the aggregate. Okay? That's very different. And this is Lucas in 1976 in the paper that gave rise to the Lucas critique, saying the model, the econometric model is the optimal decisions of economic agents. And he thought, again, explaining what he was doing, saying we should be microeconomically founded, we should be building macro from micro. Nobody was satisfied with Iceland as the end. We were going to type with microeconomics. So what you actually get when I'll be talking about this next week with DSGE models is trying to derive that directly from the model of a utility maximising consumer, called the representative agent, and a profit maximising firm, called the representative firm. Okay? That's what they're trying to do. But if you look at what Anderson had to say about this idea, it's what he calls constructionism. You're trying to start from the individual elements and add up to get the aggregate. And physicists long ago realised that wasn't possible. You can't extrapolate the properties of a single component to understand the system as a whole. And this is, again, another paper I highly recommend reading called More is Different by Philip Anderson. You can find it on the web quite easily. Lots of people have made PDFs of it. This is reductionism doesn't by any means imply constructionism. The ability to reduce everything to simple fundamental laws does not mean you can take those laws and reconstruct the universe. Now, a simplest instance of that was, if it were true that you could start from the fundamental laws and construct the universe, then the typical question in a biology exam would be, please take these chemicals and create life. Okay? Now, we can know what chemicals exist in the living body. We do not know how to put those together to create life. We probably never will. So constructionism breaks down when you have both scale and complexity. And that's the issue. The behaviour of large and complex aggregates cannot be understood as an extrapolation of the properties of a few particles, which is what neoclassicals are doing with the idea of micro foundations. It's just scientifically wrong. And Anderson says each new, if you all watched The Big Bang Theory TV show, yeah, I got sick of it now. I used to really love it. It just makes me cringe these days. But you know how Shelton is always putting down Amy because she's what, a biologist, isn't she? And that's how it's so trivial. Well, this guy's saying biology is just as complicated as physics. It's a whole new level of thinking. At each level, you've got new laws which are as fundamental as any other scale. And he said you can potentially array sciences in this way and say that chemistry, many body physics explains chemistry. Chemistry explains molecular biology. Molecular biology is the basis of cell biology, and ultimately psychology is the basis of the social sciences. But as he says, it doesn't mean science X is just applied Y. Each is a new level of thinking. Psychology is not applied biology, nor is biology applied psychology, and chemistry, and neither is macroeconomics applied micro. But that's what neoclassicals have tried to make it. That's another error at the core. So, and this is my favourite example of this. This is why I made this case last week. I asked somebody what H2O is. They said it's water. No, it's not. Okay. H2O is a molecule which, interacting with other molecules in particular temperature conditions, has the properties of what we call water. But if they were true, then it should be possible to have different states of that molecule, where there was a water molecule, an ice molecule, a steam molecule, and my personal favourite, a snowflake molecule. There's no such thing. In each case is what you get from these manifestations of large aggregates of identical molecules are emergent properties of H2O. They're not something you can derive by looking at a single molecule of H2O. It's how does H2O interact with other molecules of H2O given different environmental conditions. That's even with identical substances. Okay? You actually need, at least with snowflakes, you do need something else inside it. The other three states of H2O are all states of H2O under different conditions. Pure water, pure H2O will have those three different states depending upon the conditions you impose externally. So microfoundations is a non sequitur. We shouldn't even be trying to do it, but that's what they've tried to do. But that is, in fact, the driving force behind the design of macroeconomics. It hasn't been trying to explain observed macroeconomic phenomena. It's been trying to make it more consistent with their micro. And it goes right back to Jean-Baptiste Say, in my opinion, because when you look at neoclassical economics, of course, it's been dominant since the 1870s. Intellectually, it's had 150 years of being the dominant approach to economics. But when post-Adam Smith, after the physiocrats, the classical school of value was dominant. And people like Say were a minority player from it's a bit like a post-Keynesian talking to neoclassicals today, only they were rather more polite back in Ricardo's day that actually listened to Say and actually swallowed some of Say's nonsense, unfortunately. But Say said that producers ask for money only to use that money immediately again to buy something else. If we don't consume money, and it's not sought after in ordinary cases to conceal it, this is another Nobel Prize in economics winner, you know. So you go up and ask a wealthy person what are they worth, they'll freely tell you. They won't hold them. Why should they hold anything back? Why should they return? So producers, though they have the air of demanding money for their goods, do in reality demand merchandise for their merchandise. That's complete nonsense. But that's the starting point from which, in any ways, neoclassical theory began. And at the macro level, what it argued was that crises, when they occur, were just disproportionality. The price for something was too high, therefore supply was too high. And elsewhere there'd be, if supply is too high in one market, there'd be excess demand in another market. In the aggregate, you'd get a balanced economy. And general gluts or slumps were simply impossible. And the basic logic is money is just an intermediary. Nobody desires money for its own sake. People are simply buying to be consumers. So everybody's trying to maximize utility. Nobody is trying to make large amounts of money. You know, nobody in a capitalist economy. Give me a break. So each person's supply is therefore matched to their individual demand. So you only supply because you want to buy identical goods of identical value. That's why you supply them in the first place. And the sum of all supplies therefore can't exceed the sum of all demands. You can't have general gluts. And a slump in one market can occur only if there's excess demand in another market. So all you going to get a crisis, it's all due to government regulations, monopolies, all the things that make the market work less perfectly. And if you had a fall in the price of X, which is an excess supply, then demand for X would rise you back to equilibrium again. So the best thing to do during a slump is cut wages, okay? Because that'll reduce workers' cost to the level where employers will demand them and you get full employment again. So that's basically a micro logic. It's a hypothesis about the aggregate based on the individual. And that's, again, the classic way that neoclassicals think. You aggregate to the overall economy, give you macroeconomics. That's their vision. And it's also essentially a real, as opposed to non-monetary, argument. Now, Marx did a beautiful critique of this. And he said, Say's law applies in only one of the circuits in capitalism. You can say that there are people who have a commodity to sell, normally labour power, which they get money in return for, and whether they go and buy other commodities. They're simply changing the commodity they have, they don't want, to get another commodity they don't have and do want. And that's what he called the CMC circuit. And he's quite happy to say that, yes, that circuit is balanced, in the sense that Say argued. But there's a second, equally important moment, with money exchanges for commodity and for money again. What you're after is more money. And this is his very first expression of it, I think, in the Grundrisse. It's not just commodity, commodity, but money, commodity, money. And that only makes sense if you make an aggregate gain. So part of demand in the economy comes from the CMC circuit. He said that's fairly reliable and stable. But the MCM plus circuit you'll only do if your expectations of the money you're going to get are greater than the money you're going to put in. If your expectations that you're not going to get that money, you're not going to spend, and there'll be insufficient demand to employ everybody who wants to work in that economy. Okay? That's Marx's brilliant critique of Say's law. So you get a balance of value in the first circuit. You're exchanging one commodity for another. You're exchanging equivalents in dollar terms, and you're getting the qualitative difference in utility, which is the whole focus of the way neoclassicals talk about the economy. So seller of A, buyer of B prefers B to A, ditto and reverse. And that's where you get that nice sort of Say's law balance. But it doesn't make sense in the second circuit because it only makes sense if the amount of money you're getting is greater than the amount you're putting out in the first place. And here's where, again, Marx going through and saying that if exchanging commodities makes sense, that exchanging money for money makes no sense unless you're getting a quantitative increase. But he said in the real process of buying in order to sell, the motives of profit. Again, this is Marx being very verbose, so I won't read through these in detail. Do take a look at the segments I'm taking out of it. This is from the Grundrisse, just after he starts to discover his use value, exchange value dynamic. But he also says, of course, often people in the second circuit lose money. Okay? There will be failures, and that, of course, will lead to macroeconomic dynamics, which Marx is quite capable of understanding. So Marx accepts Say's law with respect to CMC, and he says it's valid to say demand is equal to its own supply, so long as you get proportion right between sectors. So he's conceding Say's law in the CMC circuit. He's rejecting it in the MCM plus circuit. It says the MCM plus circuit, on the contrary, commences with money and ends with money. Its leading motive is mere exchange value. And if you don't get it, that particular part of demand will disappear. Or you might get more demand than you can cope with in that particular circuit. So it's wrong from first principles. It's more complex than just simple commodity production and exchange. And you have one vital class of agents in capitalism not motivated by consumption but by accumulation. They're called capitalists. So fundamentally, Say's law is a model of capitalism without capitalists. And some of the two circuits give you aggregate demand, and you can be deficient if people's expectations of profit are deflated for whether, real or hypothetical reasons. So that MCM plus circuit is the vital one, which is neglected by Say, also fundamentally neglected by neoclassicals. And that's where you get your true cyclical dynamics from capitalism. And with neoclassicals, simply don't understand the cyclical nature of capitalism. For them, it's an equilibrium system. And they don't understand the possibility of financial crises either, which, of course, is another essential part of capitalism. So it's leaving out this MCM plus circuit. That's a major reason why they've made that mistake. And you get the two circuits, commodity, CMC, where you're trying to increase utility, and you can accept that monetary value is constant. The only thing that changes is qualitative, and Say's law can apply. The MCM plus, where you're trying to increase monetary value, utility is irrelevant. What you're trying to do is get more money in your hands, and Say's law is invalid once you have accumulation there. So what you get in the sense of an aggregate balance just doesn't apply in an actual real-world capitalist economy. I'm actually searching and looking for the time, not that I intend stopping right now because I've got to go for 2 hours flat, 5 o'clock. Can you cope with going on here, or do you need a bit of a break? Break? Okay, let's take a bit of a break. I'll just finish off that particular slide. That's it. So, again, there's a sense of a balance, which is an essential part of Say's vision. Marx's vision is that for a capitalist to actually make a profit, he's got to have a greater supply than his demand. There's got to be a gap between the two for a capitalist that has to be somehow sustainable with an overall economy, which is part of what I've been working out with my monetary models of capitalism. But fundamentally, if you have capitalists in the capitalist system, then modelling as if there aren't capitalists isn't going to work. And that's fundamentally what neoclassicals are doing and what Say has done. So the real point of the argument always comes down to what happens to labour, because it's when workers are unemployed, can't find work, strikes, political unrest, particularly during the 1800s when you had several times when people thought it was quite possible there could be a socialist revolution across the whole of Europe, and particularly in England. You only hire workers if you expect a profit. If you have your demand is derived from the CMC circuit plus the MCM plus circuit, effectively consumption plus investment in Keynes' terms. The former is very stable, the latter is extremely volatile. Only if the sum of the two equals the supply of labour. In terms of demand for labour, you're going to get full employment. So you can get unemployment, underutilised capacity and cycles in capitalism, which are what we've seen. So you leave them out by leaving out the MCM plus circuit. And funnily enough, Keynes agreed with Marx on this one. Keynes was normally quite disparaging of Marx. I don't think he actually ever read any Marx. I haven't looked at his own literature, as people like Rod O'Donnell have done, to see what he's actually read, but it appears he only read a couple of derivative books on Marx. But he loved this one. In a 1933 draft of the General Theory, he said Marx makes this wonderful observation that you don't have CMC plus, but also MCM plus. And he thought it was a fabulous observation. And this is in Keynes's draft for the General Theory in 1933. And W. Dillard covers this very well in that particular article. It's again one I recommend reading. Now, then he keeps on going and says that entrepreneurs aren't interested in the product, but the amount of money they'll get out of it. It's all very Marxist insights being used by Keynes quite effectively. But it didn't get into the General Theory itself. And what he gave was an incredibly obtuse explanation for his own logic. And it says, and Keynes writes beautifully. If you read Keynes in the economic consequences of the peace, possibilities for our children, the papers in 37 parts of the General Theory, it's beautifully written. Have a look at this load of garbage. In a given situation of techniques, income depends upon the volume of employment. The relation between the community's income, what it can be expected of consumption, D1, which is the CMC plus CMC circuit, will depend on propensity to consume. Demand for land for MD2 will depend on new investment. That's the MCM plus circuit. Since the total demand is the two added together, then we can write this function. Hence, the volume of employment depends upon supply, propensity to consume, volume of investment. That's the answer to the General Theory. What the hell was that? Okay. So the beautiful clarity of the CMC, MCM plus gets replaced by this garbage. I think the reason being, of course, he's writing in 34, 35. It's the height of fascism in Europe. It's the height of Stalin. You don't want to use anything mentioned in Marx. It's left out politically, but it hobbled the General Theory dramatically. If we had Marx's insights there in the General Theory, it'd be a much, much better book.
No one would have read it.
But nobody read it. That's the trouble. He's making a political compromise, I believe. I haven't read Roll's work on this. Yeah, but that makes sense. Now, that clumsy statement in the General Theory, thank God, was replaced by better stuff in the 37 papers. So I always recommend students to read Keynes' 1937 papers before you read the general theory. And if you can't understand something in the general theory, don't bother, because it'll be wrong or badly expressed compared to what's in the 37 papers. So it says, put it this way, not because investment is the only factor, but it's the most volatile factor. And he says, in terms of the propensity to hoard, quantity of money, state of confidence, yada, yada, yada. But of these, it's the factors that determine the rate of investment which are the most unreliable, since these are influenced by views about the future about which we know so little. And that's where he's starting to write like an angel again, as Jeff Harcourt put it. So none of this is recognised by neoclassicals who stuck with the CMC vision and have been trying to expunge, in a sense, that MCM plus side of Keynes' vision in what they call macroeconomics. Now, when you look at what macroeconomics is to them, it's essentially general equilibrium. It's taking the partial equilibrium model of a single market and trying to get a market of equilibrium in all markets at once. And that's what they want to have as macroeconomics. Applied micro, general equilibrium, that's what they're after. And Walras, of course, made the first attempt with a mental model of the Paris bourse where you couldn't trade in an individual market unless demand equals supply. So the price would be set at the previous day's price. If the traders did not reach an equilibrium of demand and supply at that price, the auctioneer would vary the price. What Walras asked himself, could you do this all markets at once? So not allow trade in any market until all markets are in equilibrium, and could the higgling process with a set of prices lead to an equilibrium outcome in the same way that haggling over one price of one commodity did lead to an equilibrium outcome? So you start with a random initial set of prices. You adjust price up in markets where demand exceeds supply. You adjust it down where demand is less than supply. Will this reach equilibrium in all markets? That's an interesting question, okay? Again, one of the things I say to students in the undergraduate course, the questions that a particular school of thought starts from often is a legitimate question you can't rule out on the very first basis saying that's a bad question. The thing is, what do you do when you get the answer and it's not what you want? That's the important thing. So Walras believed this process would work. He said, let us imagine a market with only consumer goods and services. Prices are cried out at random. Parties work out what they're going to buy and sell at those prices. The quantities are then added up. New prices are if you're not going to get equilibrium, you call out new prices in each market. Keep on adjusting up and down. Up for the ones where demand is greater than supply, down for the ones where supply supply is too high, and you'll get equilibrium prices, and then you can have exchange. Okay, so it's a reasonable attempt to cut through the complexity of a multi-commodity world to work out whether you can reach equilibrium. Not something you can rule out first of all. So it's a dynamic process, but it's out of time because you're not allowing a change to occur until you get to the end. This makes it vitally important to be able to get to the end. Because this process doesn't converge, you will starve to death. Okay? You've got the pigs there, you've got the steel, you've got the body, you've got the croissants. None of you can touch any of it until we reach equilibrium, and I'm going to use a process which doesn't reach equilibrium so you can all starve to death. And that's unfortunately what happens. I want to explain what's going on. So you get prices determining how much wealth agents have to begin with. Until you declare the prices, you don't know what your actual monetary or relative value is. And that's the supplies which are desired for consumption. You've got demand for the quantities you want as well. Each agent is trying to balance, each agent individually balances what they've got for times the price to what they've got times what they want to buy. So each agent is doing that Say's law calculation. And if all markets reach equilibrium, then you have trade. If not, then the auctioneer varies the prices, recalculates demands and supplies, keep on going until you reach equilibrium, and then you allow trade. That's the algorithm that Walras was thinking of. Will it actually converge? Well, Walras thought so. That was his final punchline. But the problem is if you change price in one market, of course it affects all the other markets. And the feedback from one then comes back to the first market as well. So it's a complicated story. And maybe those feedback effects overwhelm the direct effects. And this is the question that Walras himself could not answer. And he surmised that it would work. He surmised that when you look at the direct effects, if you have for each commodity in that individual isolated case, you are adjusting price up if there's too much demand, price down if there's too little demand. So you know in that particular case you're pushing towards equilibrium across the diagonal in the matrix describing all these transactions. But off the diagonal, they go up and they go down. Maybe they cancel out. That's what Walras surmised. He said, this will appear probable if we realise that the change for the price of P that pushed the inequality towards inequality was invariably setting market B towards equilibrium, whereas the changes for C and D, given that change for B, would push maybe C away and D towards. It says, up to a certain point, they cancel each other out. And then each new set of prices would be closer and closer to equilibrium, and you'd get there. Now, that is a legitimate conjecture. Again, you can't rule that out as a conjecture which hasn't been mathematically solved. But the mathematical solution was done later by mathematicians who didn't even know that this was an issue for economists. These are pure mathematicians. I want to go through the logic. So what you've got, imagine your simplest possible world. Your end markets, you're using commodities, producing commodities using other commodities. Everything is about supply and demand. There's no accumulation of stocks. And all output in year T becomes an input for year T plus 1. So I'm just internalising consumption in that sense. That's your simplest possible model of this. And the economy is growing over time, and for it to be in equilibrium, the rate of growth of different industries has to be identical. Otherwise, you haven't got equilibrium. So output in year 0 must be sufficient for production in year 1. That's your first requirement. And prices must enable all the producers to buy their inputs. Okay? Unless you've got those conditions applying, you can't get equilibrium. And you can express it in a set of matrix equations. So output in year T plus 1 is an output-input transformation of inputs in the previous year. Output in year T plus 1, which is x of T, which is a vector of, n entries for output in year T plus 1, is going to be a matrix A times the inputs in year. You can see which year I wrote these lecture slides in. Did a lot of copying here to get all this done in time. So there's output in 2005. There's your production process, derived from a productive matrix, so one that actually gives you net output. That's your A. And your XT is outputs in 2004, which are inputs for 2005. So that equation has to apply. Now, if you're going to get stable growth, each sector has to be growing at the same rate. So you can now do a scalar expression as well as this matrix expression above, saying each sector is growing at 8% per annum. So output in year X, T plus 1, is going to be 1 plus A, well that's a scalar. 5%, let's say is 5% growth or 3% growth, multiplied by that, and that's to apply for all the sectors. So there's your condition for stability in production terms. For a stably growing economy, output must be growing by 3%, let's say, in every sector, using input-output dynamics to produce the goods and services. Now you can combine those using matrix mathematics. So there's your first production relation. That has to equal the growth condition. So I've now got the right-hand side of both those equations has to be equal to each other. So you equate them. You now got an expression involving matrix mathematics on one side and semi-scalar mathematics on the other. Rearrange them using matrix rules. I've got to bring across the other side. My 0 now is, of course, is a column of n zeros. This is now matrix notation. I've got to multiply by the identity matrix to combine this in. So I've got A minus 1 plus A times I, which is a matrix of 1s across the diagonal and zeros everywhere else, multiplied by the vector of outputs in year xt, has to be equal to 0. So this bit, fundamentally, has to somehow be like 0 because you don't want your outputs to be 0. So you've got an expression here multiplied by an expression there equal a whole lot of zeros. You want this to be non-zero. So for this to result in a whole lot of zeros, somehow this bit is to be like 0 in a scalar sense. Otherwise, the only way to get this whole that equation is xt itself is equal to 0, so there's no output. So on a positive xt, positive output in year t, to be feasible, somehow that A minus 1 plus A times I has to be, inverted commas, like the scalar number 0. Now that's equivalent to 0 if its determinant is 0. I'm not going to go through the matrix mathematics of that, but what's called the determinant has to also be equal to 0. Now, you can also express the price condition in matrix terms. So you have prices must enable producers to buy their inputs. That means you can write for equilibrium, relative prices must be constant. Okay? P is a vector of relative prices. It's not changing. So P must be a constant vector. And the cost of inputs is P times the list of prices times the input-output relationship. That's what you need. Times the rate of profit, which is constant across all those in industries. Otherwise, people are going to want to move from one industry to another. So you want a constant rate of profit, the same for all economy, that's all markets. That times the prices, times the goods you've got to buy, has to be equal to the price vector. That's your second stability condition. That's your list of prices, which occurs on both sides of the equation. That's your uniform rate of profit. Pi must be the same for every, must be, say 5% or 7% or 10%, but it must be the same in every sector. Otherwise, people would want to move between sectors and haven't got equilibrium. And that's your table of input-outputs again, or output inputs. So rearrange that using matrix rules, and of course, here the order of multiplication matters. P times I is not the same as I times P. So you multiply both by the inverse of A. And now you get the inverse of the production, the output-input matrix turning up. A times A to the minus 1 gives you I. So you get rid of that particular part of it. So you now get P multiplied by A to the minus 1 equal to P times 1 plus the rate of profit times the affinity matrix. Move that to the left-hand side. Now you've got another column of zeros on the right-hand side. Aggregate that expression, grouping on P, and you now got another expression. Now you don't want the P's to be 0. You want to get this to be 0. Somehow this must also be like to 0. Now the other one, likes are involved A. This is likes are involving A to the minus 1. Okay? So somehow a matrix A, a property of matrix A, and a property of the inverse of matrix A must both be like 0. So that is equivalent to 0, only if its determinant's also 0. So you require that to happen. Now, matrix, has everybody done matrix mathematics here, or people haven't done it? Not much, we'll touch, okay. What an eigenvalue is it's an expression of how much a process is expanding or contracting space. So if I have this thing in my hand and I throw it that way, then I can resolve that into 3 directions, that way, and that way, for its direction of travel. And if I'm throwing it, it's going to have a positive number representing what I'm doing to it, saying I'm pushing it in that direction. So I can resolve those 3 directions into 1, and the number is positive number saying I'm throwing it away. If I'm pulling towards me, it's a negative number. Okay. So fundamentally what a matrix is, what an eigenvalue is doing is saying, am I pushing away from equilibrium or pulling towards? Defining my position in the room as equilibrium. So that's probably called eigenvalues. And it's again, that's, yeah.
What if the eigenvalue is bigger than 1?
Pardon?
If the eigenvalue is bigger than 1?
Well, bigger than 0, so there's 2 that matters. Bigger than 0, bigger than 1. I'm doing discrete time, so it's actually bigger than 1 that matters here. So it's fundamentally that's when you're working at eigenvalues, you're working with a polynomial that summarizes the characteristics of the matrix. And if you're looking at discrete time, look at year t plus 1, t plus 2, then the important value for the eigenvalue is 1. So what you want for equilibrium is to be less than 1. Okay? Now that's a problem, because A and A to the minus 1 have inverse eigenvalues. If A has an eigenvalue of 10, then A to the minus 1 has it's a dominant eigenvalue of 1 over 10. Okay? And that's a little catch. So the only way you can actually get stability out of this is if the dominant eigenvalue, as it's called, is negative. If A has a negative dominant value, because if I have minus half, the inverse of minus half is minus 2. And they're both less than 0, they're both obviously less than 1, that'll work. So Walras' condition for does this process converge comes down to Does the dominant eigenvalue of the production matrix, is it negative? Bad luck for Walras. By sheer accident, what that is, the matrix you're looking at, that tells you your input outputs, tells you use, say, 0 units of butter, okay, and 1 unit of coal, and some other things to produce 1 unit of steel. You don't use minus coal to produce steel. So what you've got in arrays are either zeros or positive numbers. And that's an interesting problem for a mathematician. Is the dominant eigenvalue of an array of what they call positive semi-definite? So it's positive numbers, sometimes 0. What's the dominant eigenvalue of that array of numbers? And that's a complicated subject in mathematics. It was solved by 2 mathematicians in the early 20th century called Perron and Frobenius. And the answer is its dominant eigenvalue is greater than 0. Now what that means is that A has an eigenvalue of, say, 0.1, which is in discrete time less than the 1, that's good. But A to the minus 1's got a value of 10. That's bad. So what it means is either your quantity dynamics are going to be unstable, or your price dynamics are going to be unstable. You won't converge. And that's, I still haven't read through the Perron-Frobenius proof myself. I've got to read it one of these days. Somebody, a mathematician I respect, said it's non-trivial. And anything a mathematician calls non-trivial is bloody difficult, so I haven't done it yet. But the basic come down is either A or A to the minus 1 must have a root, dominant root that's greater than 1. They are either your quantity process or your price process is unstable. So Walras' algorithm would not work, and if you sat there waiting for this to happen before you ate your croissants for the morning, you would starve to death. Okay? So it doesn't work as a way of reaching equilibrium in a market. And if you diverge even a tiny fraction of stability, you'll be driven away from the stability. It's an unstable equilibrium. Again, something neoclassicals can't get their heads around, unfortunately, but those things can actually exist. So what Walras was hoping was that direct effects would overwhelm the indirect. But unfortunately, it worked out the other way around. The indirect effects overwhelm the direct effects, given this production process. So if you have a plausible model of a growing economy, the feedback effects will drive you away from equilibrium. You will not get an equilibrium price vector out of this. If you want to transact, in other words, you've got to transact out of equilibrium. Okay? Now that's fine. Okay? That's the real world. But unfortunately, neoclassicals want to hang on to this vision of everything happening in equilibrium. They weren't very happy about this result. So their first argument was that it's just an artifact of matrices. A matrix is a very rigid way of describing a production process. X units of this plus Y units of that. We talk of it in terms of flexible production systems. Another one was to say, well, let's fudge it. If it's not stable on its own basis, let's make it stable. And thirdly, let's ignore it. Well, on the first one, yes, an input-output table is strictly linear. There's rigid ratios between each commodity and producing a particular output, and they've got non-linear variable Cobb-Douglas reduction function and stuff like that. And they say, well, the neoclassical model with the Leontief one is not stable. Problem with that is that if you actually take one of their models with flexible production and you break it down, it's like you get a polynomial expression for it. And if you're near the equilibrium, then the linear parts dominate, the matrix bit. So you can get away from equilibrium and be driven back towards it, which means you don't get a breakdown, and that's quite sensible. That's saying that out of equilibrium prices will not lead to economic breakdown. It'll lead to cycles, but they won't lead to breakdown. Because when you get away from the equilibrium, the non-linear terms do matter. But if you try to work out the properties of the equilibrium, then the linear terms dominate around the equilibrium. So take, for example, sine of x. That's the quadratic, the Taylor series expansion for sine of x. And sine x is roughly equal to x minus 16x cubed plus 120x fifth, yada, yada, yada. But the part that matters for linearity is just that first bit. Okay. And if that's a positive, your process is unstable, period. So the best guess for the sine of x close to equilibrium is x. And it's actually a very, very close guess, as long as you're not too far away. So the linear bit, which is the input-output matrix when you're looking at a nonlinear production system, that's what determines stability. So that's an irrelevant defence. I'll just actually show this in a bit more detail here. So this is looking at sine of x versus x as an approximation. How accurate is it? It's precisely accurate at 0. It gets more inaccurate the further you go away, but it's pretty reasonable between minus 0.5 and plus 0.5 for approximating the value of the sine of x, which is not bad. So it'll stop prices becoming crazy, but it won't make the equilibrium stable. You won't get equilibrium prices out of it. Now you can get there if you start an equilibrium, then you can remain there. If you actually start with equilibrium price vector, then you say, yep, that'll do me, and everybody walks out, and there's no iterative process. You buy what you came to buy, you sell what you came to sell, everybody's happy. But you've got to start an equilibrium to get to that point. And here's what they actually did, of course, is Jorgensen was the first person to notice it. He saw this particular problem about 40 years after the mathematicians developed the logic. Then he says, well, you need excess capacity, which is sensible. You need stocks. Stocks exist in the capitalist economy. Unsold cars, unsold hamburgers, etc., etc. But then he comes out and says, well, for dual stability, to avoid it, you need to reinterpret the basic model. So he reinterprets it here to say we should adjust people's preferences. I thought that was called fascism, not capitalism, or socialism as they likely to write it. So it depends upon people's behaviour, but he also says by suitable restrictions on the initial values. If not, if we assume we start where we want to get to, we'll get to where we want to start, or something like that. So again, it's one of these nonsense assumptions. And you even do it in stocks and a reserve bank and interest rates, trying to stabilise it. Now, this is all stuff that Walras left out, simplifying assumptions, remember? But it didn't work with the result, so it's complicated, because it looks like it works with the result. And he even got the maths wrong. John Blatt does a beautiful job of pulling that apart. And the system is still unstable. There's other attempts they try to make it stable, things they call turnpike theorems and stuff like that have died a death over time. But the dominant value became, let's ignore it, because Ara de Breuck, and this is another person I'm going to definitely nominate for the Nobel Prize in Economics, removed it completely by saying, and I love this, for any economic agent, a complete action plan made now for the whole future. Let's get rid of time. Who needs time? What has time ever done for us? Okay, literally, made for the whole future. They gave this guy the Nobel Prize. Okay? They should have put him in a room with white-padded cells. The market only occurs once in the history of the planet. All transactions for all time take place at that stage. You take insurance out in case things don't work out the way you want. And I just love this particular, when I saw this, because I had to read this damn thing from my master's course, and I thought the lecturer takes this seriously. This new definition of a commodity allows us to obtain a theory of uncertainty formally identical with the theory of certainty. In other words, uncertainty about the future is assumed to make no difference on a theory where we actually know the future. In which case, if we know the future, why do we need markets? Okay. Again, this is an elaborate failure dressed up as success. And they gave this guy the Nobel Prize for that particular set of papers. Now, I love this as some historians of economic thought start off neoclassical and slowly, as they read what they've got to explain to students, begin to realise how bad it is. I think this is Mark Lord saying that Walras actually had an abstract but nonetheless realistic description. The whole idea of the iteration to get there, it's a reasonable starting point. By the time we get to Ara de Breuck, it ceases being any description of actual economic systems whatsoever. It's a model you can write down on blackboards using terms like prices, quantities, and factors of production, but it's clearly and scandalously unrepresentative of any recognisable economic system. And yet it's so elaborate, the mathematical games they play in doing it keep them going on forever and awarding each other Nobel Prizes. So that's the state of the nation. I'm not going to get through this part of the lecture properly, but I'll do as much as I can in the time. So when you look at this vision of the macroeconomy, they were trying to reach models that gave them micro-founded general equilibrium models. And in that sense, really the first one was Hicks. The ISLM model is not a model of Keynes. It's an attempt to apply the idea of general equilibrium to work out a model of a multi-commodity economy. And when you look in Hicks, That's the key paper. So your task, which you've been given, is to take a look at that particular paper and put it together with the ISLM, Mr. Keynes and the classics, and also the ISLM and explanation. He had this interesting paper again, written published 1 year before the general theory, and Hicks was not part of Keynes's circle, so he did not know what Keynes was working on before the book came out. And Hicks actually explains what goes on here. He says that Mr. Keynes and the classics was the fourth of a set of papers I wrote during those years. The other, much less well-known, I've left out the others you discussed, is this one, Wages and Interest, the Dynamic Problem. And it was the first sketch of what would become his dynamic model in Value and Capital. He said, it shows quite conclusively the model was already in my mind before I wrote even the first of my papers on Keynes. Now, and often you'll get a historian of economic thought going back and trying to argue that this was the case. This is the horse's mouth talking. This is Mr. Ed, if you know your old American sitcoms. You don't know American, okay, the talking horse, Mr. Head. He's actually saying, yes, I ate the hay. This is seriously saying that I know I wrote this model before I read Keynes. It's not a Keynesian model, it's a neoclassical model. And I dressed it up as a model of Keynes, given the circumstances at the time and the fact that Keynes' model was so popular. So he said, as soon as I read the model, I saw some things in common. Both of us fixed their attention on economy during a period, so that's time-based element to it. They had a past you couldn't alter, a future you didn't know. Expectations would affect what happened. But there's two differences. Now, he talked about flex price versus fixed price. He doesn't actually understand Keynes properly, because Keynes argued his results would apply even more with flexible wages than fixed wages. But he does actually say this is of minor importance, so I don't actually cover that particularly in these slides. He said Keynes was talking about a short period, and this is your opening discussion was very much spot on, which is why I said give it to you to do that particular task. The short period for Marshall was a year. He says his short period in his book was a week. And literally, markets opened on a Monday, set prices on a Monday, which applied to Friday, and the whole thing began again the next Monday. Now, of course, during a week, it's reasonably valid to say you don't expect huge changes in expectations during a day, during a week. But if you're talking a year, there's plenty of reason to say expectations will change. So holding expectations fixed in Hicks's model in ultimately value and capital, but in wages and interest, holding them fixed for that week is fair enough. You can't object to that. Holding them fixed for a year, yes, you can object. He then goes and says if you actually pay proper attention to time, then you've got to be using a year rather than a week. So his ISLM didn't make sense as a summary of Keynes. And then you can talk about equilibrium. But he's saying, and this is where, again, it's a Walrasian model. It'll readily be understood that the idea of the diagram came to me as a result of work I've been doing in three-way exchange, conceiving of Walrasian models. So you have three markets. How can you represent three markets with a diagram with only two on it in two dimensions? The answer is you assume using Walras' law that equilibrium applies in the other market and you can leave it out. That only works if the two markets you're talking about are also in equilibrium. But that means when you draw the diagram, the only point that makes sense is the dot, where the two intersect. And that's what he realises and goes through in the logic in this paper. So he said, I already found a way of representing three-way exchange on a two-dimensional diagram, so I thought that could naturally be used for Keynes. Keynes had three elements: market for goods, market for bonds, and market for money. Can you see a missing market in his thinking there? No market for labour. So he's even wrong, even in that summary. Again, I'm praising Hicks to some extent here for having the intellectual courage to reverse his decisions and overrule his previous work. That's very rare in science in general, so he deserves credit for it. But even then, he hadn't thought it through properly. So he then said, in my three exchange, I had two markets. The third must also be. There's Walras' law. But equally, what he didn't look at was the Walras' law doesn't apply when you have the third market. I'm actually wondering, what's my slide here doing? Okay, that's a bit dated. So that's Hicks also if you look at the history of economic thought before the Great Depression, there really was no macro in neoclassical thought. The macro existed in Marx, it existed in the rebels, the neoclassicals didn't have it. So what Hicks did when he wrote Mr. Keynes and the Classics is try to construct what he thought a macro would have looked like before the Great Depression. This is what he's doing here. And that's John Hicks, the elder. You can tell a lot about a person's face, I think. I think it's a very gentle human being. There's an intriguing story from Paul Davidson. Paul, of course, became firm friends with John Hicks, but Hicks was a famous individual, Nobel Prize winner, etc., in Cambridge, etc., and so on. And Paul was thinking of going and visiting John on one trip to Cambridge, but decided, no, he'd probably get too many visitors, he might be annoyed. And Paul's lovely wife, who died some years ago, very, very emotionally empathic, said, no, let's go and visit him, please. And they knocked on John Hicks's door and he got a surprise. He hadn't had visitors in weeks. So, very, very nice, shy man. But anyway, in the model that Hicks outlined in Mr. Keynes and the Classics, he has an investment goods and consumption goods, so two industries, two factors of production, labour which is variable, capital which is fixed. So you've now effectively got three markets standing up here, and a given capital stock in both industries. And he said output in the classical model is a function of employment. So how many consumer goods you produce and how many investment goods you produce in X and in Y respectively depends upon diminishing marginal productivity. Prices equal marginal cost, and marginal cost is the marginal product of labour times the wage rate. It's the only variable cost. So you set your price equation there being the wages times the marginal product. Income is the price times quantity. So you've now got equals, here's his capital I. I'm using his notation here. Rather with modern notation, we'd use Y equal to C plus I, but he's got I is equal to I, X plus IY, and that's then the price calculations for it. And then the quantity of money was fixed. And this is the fun thing in his rendition of a classical model, because he said if you change the amount of money, you change the amount of output. So he has a constant amount of money, which is the velocity of money being K. That gives you a monetary value for income. And demand for investment is a function of the interest rate. So you have a supply of savings, which is also a function of the interest rate. And that's where he distinguishes what he says is the classical model from Keynes, as Keynes says the supply savings is a function of the rate of the level of income, not the rate of interest. So in the classical model, they're both functions of the rate of interest. And you can easily work out an equilibrium that way. Okay, the interest rate sets the equilibrium in those two markets. So you have a investment, output of capital goods, an interest rate function. There's your demand curve. The higher the interest rate, the lower the demand for capital goods. There's your supply. You can reach out an equilibrium interest rate. That gives you employment in the investment goods sector. And then since you've already worked out I, the total income, consumption production is a residual. That's a strange rendition of a model. This is what Hicks said was the standard classical model. So M determines I, which is total output. The interest rate determines output of investment goods. Therefore, IX determines employment in the that in terms of employment in investment goods. Consumption is a residual in this model. It's strange. I don't think it would actually be accepted as a model by the neoclassicals of the beliefs that 19th century neoclassicals had. But this is what Hicks then said, that then determines employment. And therefore, if you have a lower money wage, you'll get higher employment, because lower wage means lower prices. There's an unchanged amount of money, so incomes are higher in monetary terms. Higher sales means more employment. You get a lower real wage because of diminishing marginal productivity. That much makes sense in a neoclassical argument. He says Keynes argues that he has three equations. Now, you won't find those equations in the book. Okay. He says that he has money having a liquidity-based demand for investment, a investment demand also depending upon the interest rate, but he has supply depending upon income. So just supply of savings depending upon income. Demand for money depends upon the rate of interest, and he then says you're leading out the impact of the rate of interest on the level of savings, which he rejects as being fairly unimportant. So he says money demand and supply determines the interest rate. There's your money supply. There's money demand. That'll give you the interest rate. That determines the level of investment. That determines output via money supply, the multiplier. And if you increase the money supply, you'll increase the level of output. And if you increase the propensity to invest, you'll also increase the output. This is what Hicks called Keynes's special theory, not the general theory. This is, by the way, remember this is the time when Einstein is still the intellectual giant, still alive and kicking. And people, when Keynes said the general theory, he was thinking in terms of his being, in a sense, Einstein for economics. So this is the special theory. This is the notation which Hicks is using. There's your money supply. There's your money demand given liquidity preference. That gives you a level of investment. The level of investment determines the level of output through the money multiplier. And you finally get a level of employment coming out of that showing diminishing marginal productivity. So money, you get the interest rate being determined over here. That determines investment. Investment determines output. Output determines employment. That's his logic. Then if you have an increase in the money supply, then that, now I'll get rid of my warning for my virus protector, that reduces interest rates, that increases investment, that increases employment. So that's the logic that Hicks saw as Keynes' special theory. And so the employment will grow by more than output because of diminishing marginal productivity. So again, you get the idea you can get a big boost to employment from a small boost to output. Now, if you reduce liquidity preference, you increase employment as well. So if that curve falls and people have a lower demand for money, that's going to drop the interest rate and increase employment as well. So that's the way he interpreted Hicks, Keynes as a special theory. But what he saw as his general theory was much more orthodox. And here is Hicks doing what he always did in these days. He brings in extra elements that aren't in the original theory. And then he calls it the general theory. Now, I better leave it at that point because we're about to get the other group turning up here. I better carry on with this stuff next week. So.